Welcome to our lesson on geometric sequences. There are many lesson goals, so you're going to have to see above, but they all have to do with either finding the nth term or figuring out the parts of how to write a geometric sequence. So let's begin. A geometric sequence is a sequence that has the same ratio or the common ratio between any pair of consecutive terms. So we're going to be using common ratio a lot. With the arithmetic, the same step, we were adding or subtracting. For this geometric, we're going to be timesing or timesing between each step. And the formula used to calculate the general term of a geometric sequence is t to the n equals a r to the n minus 1, where r is that common ratio, that's why it's an R, and then A is our first term. So the A is the same symbol that got used last time, and N tells us what term we are in this sequence. Then we also are going to have, that's for the general term, so that was the general term. But then there's also going to be the recursive formula. Oh, and I'm seeing a typo right now. The recursive formula for a geometric. So let's correct that. Cross out arithmetic. It should say geometric sequence is t to the 1 equals a. So that's saying what our first term is. Then the nth term is going to be the common ratio times the term that came before, as long as n is an element of the set of the natural numbers and n is greater than 1. We're going to be using both of these formulas. So an example one, it says for the sequence 2, 10, 50, 2, 50, it's asking us what is the common ratio for this sequence. So the common ratio is going to be, so this one was asking for the common ratio. The common ratio we get by either figuring out what the step is. So here I notice it's times 5, times 5, times 5. But if we don't notice it, we can figure it out by taking the second term divided by the first term. So in this case, 10 divided by 2. And we could see that that's how it's 5. We could check again. Third term divided by the second term. 50 divided by 10. That's 5, and so on. But no matter how we do it, we're going to get that our common ratio is 5. B says determine the general term. So we're wanting the general term for this sequence. For the general term, we need A, our starting term, which was 2, R, the common ratio, which was 5, and then the general term, t to the n equals a times r to the n minus 1. That's the general formula. So for this sequence, t to the n is going to equal 2 times 5 to the n minus 1. And that's going to be our general term. C asks us for the recursive formula for the sequence. And in general, the recursive formula would be that t to the 1 equals a, and then we would say t to the n equals r times t to the n minus 1. So we say what our first term is, and then we say our nth term is going to equal that common ratio times the term that comes before. So for this question, we would say t to the 1 equals 2, comma, t to the n equals our ratio, 5, times t to the n minus 1. We would say that, and then we could throw in the other stuff that n has to be an element of the set of natural numbers, and n has to be greater than 1. But the main part of our recursive formula is going to be here, what's in the box. That's our recursive formula. Question 1, done. Example 2. Example 2 says, write the first 5 terms of the geometric sequence defined by t to the n equals 5 times minus 2 to the n minus 1. I'm going to show you 2 different ways of doing it. So the first way is just by subbing in. So this way will work every single time. It's not as quick, but you don't have to think quite as much. So if I sub in t to the 1, that's going to equal 5 times minus 2 to the 1 minus 1. So that's going to be 5 times minus 2 to the 0. So that's 5 times 1, that's 5. So I've got t1 equals 5. t2 equals 5 to the minus 2 to the 2 minus 1. That's 5 times minus 2 to the 1. That's 5 times minus 2. So that gives me t2 is minus 10. t3 is 5 times minus 2 to the 3 minus 1. 5 times minus 2 to the 2. So that's 5 times 4. That's 20. So we could do that, and we could do all of them. The second way of doing it, I'm going to do it in a different color. The second way of doing it is to figure out A and R. So the second way is to figure out A and R. So if we look at this question here, this first term out front, that's going to be A. So A equals 5. This number inside the bracket, that's going to be our R. So R equals minus 2. And if we remember, A is really our first term. So that tells us that T1 equals 5. And if I were to write this, I'm going to have to times each step by minus 2. So times minus 2 times minus 2. Each time I'm going to be multiplying by minus 2. And if I were to write that out, 5 times minus 2 is minus 10. Hey, that's what we got before, so that's good. And then times minus 2 again gives me plus 20. Then I'd get minus 40 and plus 80. So whichever way you do it, I find the second way faster, but the first way is always going to work for you. Example 3. For the function f of n equals minus 3 times 4 to the n minus 1, it wants us first to find the values of a and r. So a is this number out front, so a equals minus 3. And r is going to be the number inside the bracket, so r equals 4. It now says that it wants us to find the 6th term in this sequence. So the 6th term is to find the 6th term, we're going to need to know the nth term. So t to the n equals a times r to the n minus 1. T to the 6 is going to equal a is minus 3 times r is 4 to the n, which is 6, minus 1. So that's minus 3 times 4 to the 5. So that's minus 3 times 1024, if we do that on our calculator. And we get that our 6th term is 3072. For part C, it wants us to write a recursive formula for this sequence. So T1 equals minus 3, because we always say what our first number is. And then t to the n is going to equal r, which is 4, times t to the n minus 1. With this stuff about n being an element of the set of natural numbers and n being greater than 1. This is going to be, our recursive formula. Example 4. Example 4 says find the number of terms. Number of terms means we're looking for n. In the geometric sequence, 52,612,659, another big number, ... 11. So it wants us to figure out how many terms there are from 52 million, big number, all the way down to 11. We're going to have to figure out a couple things. The first thing we're going to have to figure out is going to be the common, we know what A is. A and R are going to be the first things we figure out. So A is going to be 52 million, 612, 659. Our common ratio we can get by taking the second term divided by the first term. So that'd be 17, 537, 553. I'm just copying that second term. Divided by 52, 612, 659. And when we simplify that, we get that R equals 1/3. I guess it didn't need to be in a box, but it's in a box now. If we were to write out the nth term, or the general term, t to the n equals, we're trying to figure out how many terms will get us to 11. So t to the n equals 11. That's going to be 50, A is 52, 612, 659, times 1/3 to the n minus 1. And this formula right here is what we're going to solve to find n. And we're going to have to use logs to find it. Just a little log reminder. I will do this in pink right here. If we have 2 to the 3 equals 8, we could write down, 2 to the x equals 8. We know it's 2 to the 3. 2 to the x equals 8. We could write that x equals log base 2 of 8. That's a reminder about logs. So if that's our reminder, and we're trying to find out what n to the minus 1 is, first we're going to have to make it a little more simplified. So the first step would have 11 over 52, 612, 659 equals 1/3 to the n minus 1. I can then use the pink log rule to write down that n minus 1 equals log base 1/3, the base of the power is the same as the base of your log, times whatever was over here. So all of this is going to go here. So log base 1/3 of 11 over 52612, 659. And when you punch that in your calculator, remember you got to hit double log on our calculators. Double or triple? Ln, log, triple. So you press the ln log button 3 times. You're going to get that whole thing equals 15. So take a second right now, pause, try it on your calculator, make sure you can get 15. 14. Make sure you can get 14. We get 15 when we move the 1 to the other side. We get n equals 15. So therefore, there are 15 terms in that particular sequence. Example 5. In a geometric sequence, they give us the 5th and the 7th terms. And then they want us to find the formula for the nth term. So we're still going to be looking for A. We're trying to find out what A equals, and we're trying to figure out what R equals. They've given us T5 equals 1875. T6, we don't know. T7 equals 46,875. And if we think about this, each time to get from one term to the next term, we'd be multiplying by R. So we could write that if I had 1875 and I multiplied it by R and multiplied it by R again, or 1875 times R squared, that's going to give me my 7th term, 46875. I want R squared by itself, so I'm going to take 46875 divided by 1875, and I get that R squared equals 25. That means that the square root of both sides is going to give me R. And we got to be careful here because R can equal either plus or minus 5. Either one. When you square it, it's going to give you 25. So we found R That'll be the first step. Second step is going to be to find A. So if we're going to find A, find A. So the first one was for finding R. If we're going to find A, I'm going to write a general term of this formula. So t to the n equals A times r to the n minus 1. That's our general. And we're going to use our fifth term, use the fifth term to find A. So we know that t to the 5 equals 1875. So t to the 5 is 1875. But we know that also equals A times plus or minus 5 to the 5 minus 1. So I'm going to have to do two separate versions, I think. 1875 equals A times plus or minus 5 to the 4. Oh, and actually I won't, because whether it's 5 to the 4 or minus 5 to the 4, we'll both always get a positive answer. So 1875, there's just one answer there, equals A times 625. Divide both sides by 625, and I get that A equals 3. So I have R, I have A. I'm going to put this all together to find my general term. So my general term is going to be A, which is 3, times R, which is 5 or minus 5. I'm going to have to write out two options to the n minus 1. So in this case, we're going to have two answers for our final general term. Last example, example 6. So example 6 says a company has 3 kilograms of radioactive material that must be stored until it becomes safe after 1 year. So that 3 kilograms, that's going to be our A. That's our starting value. A equals 3. After 1 year, 95% of the radioactive material remains. So each year, we'd be multiplying it by 0.95. So that's our R. If they wanted to make it harder, they could have said that after 1 year, 5% is lost, and you'd have to work backwards and figure out that 95% is left. It's asking us how much radioactive material will there be after 100 years. So after 100 years, we know that they're saying for n equals 100. That's the third part of this question. So our general term is always A times r to the n minus 1. They want us to find the 100th term. So A is 3 times r, 0.95. N is 100 minus 1. So that's going to be 3 times 0.95 to the 99. And when we do that, we get 0.019. Units would be kilograms. If you were being fancy, you could write 19 grams, but you don't need to. And so our therefore sentence statement would be, therefore, there would be 0.019 kilograms of material left. Homework's down here. Thanks for watching. Make sure to check into the Zoom conversation in case you have any questions.